So, children, we are talking about valence shell electron and the octet rule. So, the octet rule states that any electron which assumes a total of 8 electrons in its outermost shell, that would be termed as a fulfillment of the octet rule, and the particular compound would be very, very stable. However, always it is not possible to obtain the octet rule just because of the nucleus size restriction and the force restriction. So now proceeding on from bonding, I would come up to alkenes. Alkenes, we have touched base slightly about the fact that they are the most simplest group, and the general formula would be CnH2n. For example, the CnH2n plus 2 basically, because if I talk about methane, methane is CH4, ethane is C2H6. So if you see the concept, it is CnH2n plus 2. Even for methane, Cn, n in carbon is 1, H2n, 2 ones are 2, plus 2, 4. So methane is CH4. Going by that fact and going by that rule, the octet rule had already been fulfilled by valencies. So this is a type of continuity or repetitiveness in the naming the compound in a homologous or a heterologous series. Such a kind of process was laid down by IUPAC, which is International Union of Pure and Applied Chemistry. Homologous series again here was a new term. So homologous series was that kind of a series which had repetitive properties, as in if the first member of the group showed some kind of a property, the entire group will show that particular property but with ever changing characteristics or a few features to it. As you must be aware that when some compounds, here organic compounds, they increase in size, they no longer would be soluble in water, as because they assume a waxy state which is not soluble in water, but that is soluble very nicely in case of organic compounds or polar solvents. When I talk about polar solvents, what I mean here is those solvents which have at least one kind of a organic component attached to it, namely benzene, benzoic acid, alcohol. So going by this policy, IUPAC established that the nomenclature has to be done in the same order, and that shows some kind of a repetitiveness in properties. Chemical properties also, if you see, those kind of ions which have extra electrons would become very ionic and would be fast to react or to combine with someone. So, my dear children, if you go on to follow the IUPAC system of nomenclature, you will observe very nicely and very comfortably that the parent series, which I refer to as methane, butane, alkane, have their names ending with ANE. They have a general formula CnH2n plus 2. On the other hand, CnH2n, which is alkene, they have the name ending in ENE. So, similarly, when we proceed down the lines of organic chemistry, we would see that there is a similarity between each group. For example, if you have an alkyl group, you will see that AlKANE is replaced by AlKYLE. So ANE gets replaced by YLE. What IUPAC had mentioned in this is they have a set pattern of naming every compound. Thereby, you or I would not face any difficulty if we follow that kind of a rule. For example, if IUPAC tells us to name butane as butane, there has to be a similarity, right? So going by that point, if we follow IUPAC, the nomenclature will be very simple. You will not have to learn it by heart. You will have to understand it. So as I was telling you before in the first video, that concepts need to be clear now when you are starting on making up your base. Okay. So proceeding down the line, we have alkenes. Alkenes also prepared gradually in the same way. However, at this point, my child, I would deviate from the topic of organic chemistry once for a few minutes or a few lectures and go back to the bonding point. Why do I want to go back to the bonding point is I want you to talk to you all about bond enthalpies and what kind of a melting and boiling point they show. So children, since the ionic bond is very very strong, they display a strong bond intermolecular force between them, as a result of which the bond enthalpy is really high. What basically is bond enthalpy? I'll let you know. Bond enthalpy is the energy that is holding the two electrons or the two atoms of a molecule with each other due to the ionic bond being formed between them. So, in order to break this bond enthalpy and have a chemical reaction in place, we have a external kinetic energy which was referred to as earlier the reaction energy. However, there could be some elements or some atoms which have a greater energy need than the reaction energy. So then we have something called as the activation energy. Hmm. So children, while I was talking to you about the bond enthalpy and the extra activation energy needed, that was very important as that is what chemistry is all about. So going back to bond enthalpy, even the van der Waals forces and the polar bonds are important for the chemical reactions to take place. You would say van der Waals forces, you understand what about the chemical bonding or the van der Waals bonding. So children, we shall be discussing about these facts when we meet the next time. Till then, take care.